Welcome to your last hour of getting ready for that big final. So I figured that today I could go over rationals and higher degree polynomials. So that's what you're in for here for the next few minutes. I know that you have already taken this test. You've already taken the cumulative that covers rationals and higher degree polynomials. But it was a while ago now, and we're now, when you're watching this video, we're down to just a couple days from your final. And these were some of the tougher concepts. All right, first of all, I'd like you to copy this little graph down. If the teacher needs to pause the video if necessary, that'd be great. And I'd like you to write the equation for this. If this is at -2 and this is at 3, then what's the equation for this polynomial? I'll pause for a second while you give this a try. Okay, you should have said that since it's going up on the right, did you even check for that? Because if it was going down on the right, you would have put a negative, right? But since it's going up on the right, you have a positive lead term, lead coefficient. And since we have an x or a -2 here, we're going to have an x plus 2. And then since we have a positive 3 here, we're going to have an x minus 3. And that would be a parabola. So clearly that's not the right answer. So hopefully you remembered there's a little squared here and here because these were both bounces. Okay, so just a reminder, this is in factored form, and you know these are the x-intercepts right here and here, and that tells us what factors to put here and here. These are called multiplicities, and they're both degree 2. All right, so that's an example of a type of question you had to be good at. Here's another one. Let's see if you remember how to do this. If I put a 3 here, and then a 1 and a -5 and a 2 and a question mark, can you drop it like it's hot and do the synthetic division here? Let's see if you remember how to do synthetic. And then when you get to the end, we'll figure out what this question mark would have had to have been for this to have a remainder of 0. All right? And then when you're done with that, I'd like you to take what you have left and make the factors that would be represented. I'll pause again while you give this a try. Okay, so you drop the 1, you multiply by 3, you add these down, makes -2, you multiply, makes -6. You add them down, makes -4, you multiply, that would make a -12. And that tells you that this question mark would have been a 12 in order to make us have a remainder of 0 at the end. Okay, this 3 drops down and we've got an x minus 3 factor for that. And then this is the constant, so it's -4. This -2 has an x on it. And this is an x squared. I could say 1x squared, but it's cleaner to just say x squared. All right. Then the question would be, did you even think about factoring it again? So the original problem, you would have used synthetic here to get this answer. Then you would have been factoring it again if you could. So x and x, and since the last number is negative, it must be a plus and a minus. And it would have to be a 4 and a 1 or a 2 and a 2. And there isn't any way to make that one factor. So we would have been done. All right, really common for people to get confused about getting it factored all the way. And they might get it factored to like x squared plus 4 and x squared minus 1 and forget that it can be factored the rest of the way. So let's do one like this. Factor it the rest of the way and then find the real solutions and the imaginary solutions. I'll pause for a second when you give that one a try. Okay, first, for factoring it the rest of the way, this one was x plus 1 and x minus 1. oops, minus 1. And this one doesn't factor any further. The kind that are perfect squares but have a plus in the middle, that kind can't factor. Okay, so now I've got my real solutions are these, and that's x equals 1 and x equals negative 1. This would give me my imaginaries. Now, how do I know they're imaginary? I'm just kind of used to doing them. You might not know for sure until you set x squared plus 4 equal to 0. And then you would subtract 4 from both sides. X squared equals negative 4. And right here, everybody should have been aware that you're getting imaginary answers because you just square root of a negative. Absolute value of x, very commonly forgotten, equals 2i. And since it's an absolute value, this is telling me I get two answers. X equals 2i, and the other one is x equals negative 2i. All right, so those are my two imaginaries, my two real solutions. That means this problem, if multiplied all the way out, would have had an x to the fourth as its lead term. And the x to the fourth there tells us a couple things. Let's review that for a second. Since it's positive in front, we know that it's going up on the right. Since it's an even degree, that means that it's got both ends going the same direction. And since it's positive, they must be going up on the right, so they're both going up. All right, and that tells me there's 4 solutions. And there were 2 imaginaries and 2 reals. And this is the only kind you can see on a graph. Those would be x-intercepts on the graph. All right, I hope that was a good review of the higher degree polys. You know, one more thing, really common for kids to get this kind wrong. Let's say that we had a nice simple line like this, but it's got a hole right above the 3. Can you write the equation for the straight line that would have a hole at 3? Let's see if you remember how to do this kind. I'll pause while you give it a shot. Okay, so if I started this with y equals x, that is a nice simple equation for the red line there. It's got a slope of 1 and it's going through 0, so that's the equation. I could put 1x plus 0, but they'd be the same exact thing, right? And then I need to include the fact that there is a hole, and so I put a fraction like this, and here I put an x minus 3 and an x minus 3. Okay, so that's going to conclude our higher degree polynomials, and we've started in with the rationals. You can tell this was a rational one right there. So let's talk a little bit more about the rationals. So if you're going to review for this, the thing that kids got wrong the most was graphing and graphing the rationals. And in the rationals unit, they don't always come out to 1 over x, but boy, if there isn't a 1 over x on this final, I'll be very disappointed, because that's the most basic rational function. So would you just take a second and graph that one? I'll pause for a minute. Let me give that one a try. Okay, now you may have forgotten what it looks like. If you did, what you should do is make an XY chart. It's your best friend in graphing. There'll for sure be a bunch of graphing on this test, and this way works for all of them. So if I wanted to find a bunch of points, I could put in a 1 for the x, and then I'd have a 1, and then it's y equals 1, 1, 1. There's a dot right there. And if I wanted to put in a 2, then I'd have a 1 over 2, which is 1/2, 2 comma 1/2. And if I wanted to put in a 1/2, that's kind of a tricky one, then I'd have a 1 over 1/2. And if you don't know what happens there, 1 over something means you flip it over. So you'd get 2. So 1/2 comma 2. And now look at that. You're starting to get the idea what this looks like? Now I hope you memorized what it looks like. It looks like this, and it has asymptotes here and here. So a couple things to remember about your horizontal and vertical asymptotes. If you're talking about the vertical asymptotes, it's whatever makes the bottom 0 but doesn't make a hole. Okay, so what makes the bottom 0 is 0. And that one's not a hole because there isn't another x on top to cancel it out. That's why we have an asymptote line right here at x equals 0. And then there's those Bob, Sob, and Bot rules. So for instance, let's say you had one like this that was like x plus 1 over x squared plus 2. That's bigger on the bottom, bigger degree on the bottom. Well, there's 3 different ways it can be. There's bigger on the bottom, bigger on the top, or same on both. And the bigger on the bottom kind are usually y equals 0, but I say that Bob is an outsider because if there's anything on the outside, like plus 3, then the whole thing's going to move up 3, and it's whatever's on the outside. Usually it's 0. But in this case, since I just put a 3 there, then it'd be y equals 3. Bigger on the top, if the degree's bigger on the top, then you have no horizontal asymptotes, so no bots. And last but not least is the same on both. So if I make this one be the same degree on both top and bottom, then I'd have like an x squared on the top and an x squared on the bottom. Then that's the same degree on both. And then I would use a ratio of the lead coefficients. So if I had this one, that would be a same on both, and the horizontal would be y equals 1 over 1, which is 1. Okay. So let's do one last one where you actually need to graph something. So I'm going to suggest that you pull up and put some grid lines on your blank Notability doc, and that you try to graph this equation that I give you. Y equals x to the third plus 3x squared plus x plus 3 all over x plus 3. Now I'd understand if you thought that you could cancel these two, but you cannot cancel those two, okay? What you do need to do is you need to factor the top and factor the bottom, and then you can look into canceling. All right, I'm going to give you a second. And then the goal of this was to graph this. So if you pull up some graph paper, next what we're going to do is go and graph what's left. But please, 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 for your own good, write the equation that's left after you factored and simplified it. Write the resulting simplified rational function. All right, I'm going to pause while you give this a try. Okay, you're back. So what you should have done to factor this is the factor by grouping. See how both of these have an x squared in them, and you factor it out and you get an x plus 3 left. And this has a 1 that you factor out, and then there's an x plus 3 left. You have to do all that? Yes. You can't just cancel this because it's part of an add problem. All right, so now on the bottom, I still have x plus 3. But a lot of people didn't actually finish this thing and factor the top the rest of the way. So factoring it the rest of the way, we have an x plus 3 that factors out of both parts, and then an x squared plus 1 is left, all over x plus 3. And when these cancel, it creates a hole, and super important, did you write y equals x squared plus 1? Because that's what you're graphing. And you probably know what that looks like. It's a parabola, but shifted up 1. Now, if you forgot like how all that works, you can just make an XY chart, graph enough points, and you'll find your parabola. You know, stick in 1. Okay, 1 squared is 1 plus 1 is 2. 1 comma 2. Okay, and that's over 1 and up 2. And long story short, your parabola looks like this. But there's a hole, Mr. Server. Yes, at x plus 3. So negative 3 makes the hole. So I go over here to negative 3. I need to extend my graph up a little further to see where that hole would be. This was the most marked wrong question, I think, on your most recent, okay, I got a little bent, let me fix that, there we go. On your most recent cumulative test, it was graphing one like this. I think it had to do with just the fact that a lot of kids didn't finish it and actually do this final simplify and write. That's what I'm graphing, because I think most of you know how to graph that. It's a parabola, shift it up 1. Right, with a hole because of this. All right. Well, I hope that helps. That's going to get you ready for the final, the last couple topics there. And now what you should do for the rest of the hour is there's a practice final and there's a key for the practice final. You'll note there is no Dropbox. There's no place to put it. You got to get used to the fact that when you get to calculus, the homework is on you. You'll realize if you don't do it, you probably won't pass the class. But it's got to be on you. You have to have the internal motivation to do your practice so that you do well on the final. So do that practice final, check it against the answer key, and I hope that you study up and you have an amazing final test. All right, have a great day.